Welcome to Marine Operations at the Lyell Centre. My name's Oliver Pepe and I'm Head of Marine Operations, and we're currently standing in the yard where we store containers when they're not offshore and on projects, and we undertake operations for scientific research expeditions, including for the International Ocean Discovery Programme and for many UK and international programmes. And now I'll just take you on a little tour inside so we can see the equipment and some of what's going on. So here we are in the Marine Operations Workshop, where we develop and maintain and test the equipment that we take offshore to sample the seabed. This is a corer that we call RD1 that is lowered from a ship, from a research vessel, on a wire and sits on the seabed. It actually has legs that you can't see, that aren't here, and it will drive a barrel, a core barrel, into the seabed up to 4 meters by vibrating the barrel into the seabed to take samples of sediments. Now we're standing in front of our latest bit of sampling equipment, which is called RD2. And this equipment has been developed and designed in-house by Marine Operations to be able to core up to 50 meters below the sea floor. So in order to do that, we lower this entire frame that you can see in front of you down to the seabed, and it sits on the seabed and then drills lengths of core barrel into the seafloor. We handle the core barrels and drill rods using a robotic arm, which we'll show you more about in a moment. The frame itself is lowered to the seafloor using an umbilical winch, which you can see behind you. This has 4,000 meters of cable on it, so that's 4 kilometers or about 2.5 miles of cable to allow us to get to some of the very deepest parts of the sea floor. The top of the cable is then connected to our control container where we operate the equipment from on the research vessel.
Hi, I'm Connor. I'm a mechanical engineer here with the British Geological Survey. This is a robotic arm that we use on our subsea drilling rig. Basically, this is a drill rod. The robotic arm gets extended out to grab onto these, and then it gets retracted back in and swung round to the drill centre. So the tool rack has a 320-degree range of motion in the tool arm. It goes from this side all the way around to the other side. It stores drill rods in one slot, core barrels in another, and that allows us to add core barrels to the drill string as we're drilling. It's semi-automated and it's controlled from our control container, which you will see later on. And it's got a vertical travel as well as a horizontal travel, as well as these grippers which we can control from inside the control container.
So Connor's just shown you the tool arm in operation, moving one of the drill rods around in the drill. And here are some other examples of the drill tools that would be mounted in that tool rack. And we have a selection here, but essentially they're drill rods. These are what gets pushed down into the sediment. And then inside a drill rod, we would lower a core barrel. So this is what would actually take the physical core, and it gets lowered down on a rope inside the drill rods. And right at the business end of the drill, we have a drill bit. So this gets attached onto the end of one of these tubes. And this has little bits, and literally this gets turned around just like a drill would do, and will drill into sediment and rock. If you want to drill just a hole rather than take a core, you can then fill in an extra bit and it becomes a solid drill bit. So we talked about the umbilical winch, and at the top of the umbilical on the ship, we have our control container from where we operate the drill whilst it's on the sea floor. So here in the control container is where we operate the equipment whilst it's on the seabed. We would have 2 people normally operating the drill at any one time, and they have a view from 8 different cameras on the drill of what's going on, and many different sensors that they can use to assess the progress of the drilling, how deep we are, and how things are working, and obviously any warnings or problems that might be emerging so that we can deal with them at that time.
The sampling system is a 5-ton system and can drill down to maximum water depth of 2 kilometers. As you can see, it has 2 ways of coring. It's got a vibrator and it's got a rotator system down the bottom. So it depends through what sediment you want to drill. It can core through hard sediment using the rotary system or through soft sediment using the vibration system.
So once the cores have been extracted on deck, they're then stored on the ship carefully until we get back to port, and then they're shipped to an onshore core repository where they're kept carefully for future scientific analysis. The cores get used for many, many different purposes. Some of our recent expeditions have been targeted at understanding deep-sea minerals and the potential for carbon storage in underground subsea reservoirs. So I hope you've enjoyed our brief tour around the building here today. And if you want any more information on anything that we've talked about or any of the science or technology that is developed and undertaken here, then please go to the BGS website where there is a wealth of information.